Now let's talk about the ADF and KPSS test performance when the model that we're trying to assess actually is stationary. So the ADF and KPSS tests try to detect non-stationarity, but what happens when we don't want them to detect that because the actual realization does not have a unit root? So again, reviewing the augmented Dickey-Fuller test, the ADF test, we know that the null, again, has the model does contain a unit root, and the alternative is that it does not. And we're going to assess this now and saying, hey, we've got this realization that does not have a unit root. What happens if we apply the ADF test to it? We would like to say, oh, a good, well-performing test then would not detect non-stationarity. And in the ADF test, it would reject the null hypothesis. So recalling that when tau, when the test statistic is less than the critical value, that's when we're rejecting. Since we're going to give it a since we're going to give it a stationary time series, the correct decision for this model would be to reject the null hypothesis. So when we look at this, well, let's just test it out real quick. So when we've got it over here, this is how we're going to do it. We're going to, again, load the IRCA and TSWG packages. And this would be generating, notice I'm gen.arima, but I don't have a d equals 1 in here this time. This used to be a d equals 1. Now it's a phi equals, it's an AR1 with phi 1 equal 0.999. So it's right up against the unit circle. It's almost non-stationary, but we know that this is stationary with heavy wandering. And so a well-performing test, again, would detect this. So depending on which test you're looking at, it would not detect non-stationary or it would detect stationarity. So, so again, I'm going to go ahead and run that. And that just generated a stationary time series. I'm going to run the test, the ADF test, that's ur.df. So I run that. And let's check it out. And so there is, remembering here, this is the test statistic. So this is negative 2.4598. And let's check out. So again, just look at the indexing that will isolate it for us. And then the critical values, we want to select the 5% critical value of negative 2.89 and isolating that one. And we note that this is bigger. It's getting close, but it is still bigger. And thus, since it's bigger, we are going to fail to reject the null hypothesis. We'd only reject it if it was smaller. This one's bigger, so we're going to fail to reject the null, thus concluding from the ADF test that the model does contain the unit root when actually we know it doesn't. So it made a mistake here. So what we're going to do is look at that a bunch of times again. We're looking at this 1,000 times, give it 1,000 realizations. Note that each do not have, it's right up against it, so it's kind of hard for this test, I agree, to detect it, but a well-performing test would detect this. How well does it do when it's almost non-stationary but still stationary? So we're going to do that. Notice that we are recording a 1 as when the test statistic is greater than or equal to that critical value. That's when we are failing to reject here. Great. So again, this will take a little bit of time, but we would love for this to be small, right? We'd love for this to be, we don't want it to make an incorrect decision. So we'd love for this to be small, but this is almost 95%. And that's what we're finding. Note here, as we flip back, this was for realizations of size 200. And so looking at this table, that's what we did in the table. Simulation results showing percentage of 100. We actually did 1,000 realizations of length 200. We found that was about 95% when phi 1 equals 0.99. We'd like for this to be small as possible. What this is kind of showing us here, what this is showing us, is that the ADF test is detecting this non-stationary behavior quite a bit, way too much. If we recall back when we were looking at, in fact, we can flip over here to the book, looking at both these tables together. This is the one we looked at in the last video. When there is a unit root, it's detecting it 91% of the time. Well, let's look at n equals 200. It's detecting it 95% of the time when there is a unit root. The problem is when there's not a unit root, it's also detecting a unit root. So the ADF test looks to be just detecting a unit root a lot of the time, so it's going to look like it's doing really well when there is a unit root, non-stationarity, but it's not going to do very well when it's close but still stationary. It's still going to detect the unit root. So, so that's kind of what we're finding here. This is when it's really close to being non-stationary. This is a little bit less, right? Still 0.99 is pretty darn close to the unit root, to the unit circle. But at phi1 equals 0.95, we're backing off of it. And even at phi1 equals 0.9, this is getting kind of far from non-stationarity, still wandering a bit, but it's still making the incorrect decision 17% of the time. So a real concern when you've got kind of roots close to the unit circle. So that's the one we're looking at there. But what about the KPSS test? Note, again, over here, we said with the KPSS test, when there is a unit root, it's doing a fantastic job of detecting unit root when there is a unit root. But how well is it detecting a unit root when there's